In this video, we are going to see about comparator using op-amp. What is a comparator? Comparator is a device that compares the input voltage of op-amp and produces the output. Comparator compares the signal voltage applied at one input of operational amplifier with known reference voltage at other input and produces high or low output depending on which input is higher. Comparator is an operational amplifier in open loop configuration. Comparator is also called as voltage comparator as it compares the input voltages and produces the output. There are two types of comparators. They are non-inverting comparator and inverting comparator. Let's see about non-inverting comparator. The signal voltage is applied in the non-inverting terminal. Therefore, the comparator is called non-inverting comparator. The reference voltage is applied in the inverting terminal. The reference voltage can be either positive or negative. For open loop configuration, the output voltage V0 will be equal to the product of open loop gain AOL and differential voltage VD. Differential voltage VD is the difference between the voltage applied at the non-inverting terminal and the voltage applied at the inverting terminal. VD is equal to Vin minus Vreference. Let's consider the case when Vreference is positive. Let's assume that Vreference is plus 2 volts. When Vin is greater than Vreference, that is, when Vin is greater than plus 2 volts, the differential voltage Vd will be positive. Therefore, the output voltage will be plus V saturation since Vd is positive. When Vin is less than Vreference, that is, when Vin is less than plus 2 volts, the differential voltage Vd will be negative. Therefore, V0 will be minus V saturation. This is the diagram of non-inverting comparator. The signal voltage is applied at the non-inverting terminal and Vreference is applied at the inverting terminal. Let's consider the waveform of non-inverting comparator. Vreference is positive, which is given by the red line. The sinusoidal wave is the input voltage Vin, which is the signal voltage. 0, 1, 2, 3 are the intersecting points. From 0 to 1, Vin is less than Vreference. Therefore, the output voltage V0 will be minus V saturation. From 1 to 2, Vin is greater than Vreference. Therefore, the output voltage will be plus V saturation. From 2 to 3, Vin is less than Vreference. Therefore, the output will be minus V saturation. And so on. Now see the transfer characteristics. Here Vreference is positive. Vout is taken along the y-axis and Vin is along the x-axis. When Vin is greater than Vreference, the output voltage Vout will be plus V saturation. When Vin is less than Vreference, the output voltage Vout will be minus V saturation, which is shown in the graph of transfer characteristics. Now let's consider Vreference as negative. Let Vreference be minus 2 volts. When Vin is greater than Vreference, that is, when Vin is greater than minus 2 volts, the Vd will be positive. Therefore, the output voltage will be plus V saturation since the differential voltage is positive. When Vin is less than Vreference, that is, when Vin is less than minus 2 volts, the differential voltage will be negative. Therefore, the output voltage V0 will be minus V saturation. Now let's see the waveform. Vreference is negative here. The sinusoidal wave is Vin. 0, 1, 2, 3 are the intersection points. From 0 to 1, Vin is greater than Vreference. Therefore, the output voltage is plus V saturation. From 1 to 2, Vin is less than Vreference. Therefore, the output is minus V saturation. From 2 to 3, Vin is greater than Vreference. Therefore, the output voltage V0 will be plus V saturation, and so on. Now, let's consider the transfer characteristics. Here, Vreference is negative. Vout is taken along y-axis and Vin is taken along x-axis. When Vin is greater than Vreference, V0 will be plus V saturation. When Vin is less than Vreference, the Vout will be minus V saturation, which is given in the transfer characteristic graph. Now let's talk about inverting comparator. The signal voltage Vin is applied in the inverting terminal, therefore the comparator is called inverting comparator. The reference voltage is applied in the non-inverting terminal. Reference voltage can either be positive or negative. In first case, we will take Vreference as positive. Let us assume that Vreference is plus 2 volts. When Vin is greater than Vreference, that is, when Vin is greater than plus 2 volts, Vd, which is the difference between Vreference minus Vin, will be negative. The output voltage V0 will be minus V saturation since the differential voltage is negative. And Vin is less than plus 2 volts. That is, when Vin is less than V reference, the differential voltage Vd, which is V reference minus Vin, will be positive. Therefore, the output voltage V0 will be plus V saturation since Vd is positive. This is the diagram of inverting comparator. The V reference is applied to the non-inverting terminal and the signal voltage Vin is applied to the inverting terminal. This is the waveform. V reference is positive. 0, 1, 2, 3 are the intersecting points and the sine wave is Vin. From 0 to 1, Vin is less than V reference, therefore V0 equal to plus V saturation. From 1 to 2, Vin is greater than V reference, therefore V0 is equal to minus V saturation. From 2 to 3, Vin is less than V reference, therefore V0 is equal to plus V saturation, and so on. Now let's consider the transfer characteristics. Here V reference is positive. When Vin is less than V reference, V out will be plus V saturation, and when Vin is greater than V reference, the V out will be minus V saturation, which is shown in the graph of transfer characteristics. Now let's consider V reference as negative. When Vn is greater than V reference, that is when Vn is greater than minus 2 volts, the differential voltage Vd will be negative. Therefore, the output voltage will be minus V saturation. When Vn is less than V reference, that is when Vn is less than minus 2 volts, the differential voltage will be positive. Therefore, the output voltage will be plus V saturation. Let's consider the waveform. Here V reference is negative, 0, 1, 2, 3 are the intersection points. From 0 to 1, Vn is greater than V reference, therefore V0 is equal to minus V saturation. From 1 to 2, Vn is less than V reference, therefore the output voltage is plus V saturation. From 2 to 3, Vn is greater than V reference, that is V0 is equal to minus V saturation, and so on. Let's consider the transfer characteristics. Here Vn is less than V reference and V reference is negative. When Vn is less than V reference, the output voltage will be plus V saturation, and when Vn is greater than V reference, the output voltage will be minus V saturation, which is shown in the transfer characteristic graph. Now, the above are the examples of ideal comparator. Practical comparator. Practical comparator will have two diodes connected between the terminals of op-amp in anti-parallel fashion. These are called protecting diodes or clamping diodes. These diodes protect the operational amplifier from damage if excessive differential voltage is applied. Now let's discuss about the characteristics of comparator. Speed of operation of comparator. The comparator should respond immediately after the input is given. The response time must be high. The bandwidth of operational amplifier must be wider. Wider the bandwidth, higher is the speed of operation of comparator. Accuracy. The input difference voltage is required to change the output of the comparator. See the diagram below. 50 milliwatts is the input difference voltage. 50 millivolts is required to change the output of the comparator. If it is less than 50 millivolt, comparator will not change state. Compatibility with output. When output of the comparator is not compatible with logic families like CMOS, TTL, Zener diodes are used to limit the swing of output. In the figure, along with the comparator, Zener diodes are used to limit the swing of output. Now let's see the application of comparator. Comparator has various applications. Zero crossing detector. Comparator can be used as a zero crossing detector. Zero crossing detector is a comparator with zero reference voltage. It is used to transition for sine wave when input crosses zero voltage condition. It is also used to control AC switch. It is a sine wave to square wave converter. The comparator can also be used as signal generation and transmission. Comparator is used as window detector. Window detector is a comparator in which the output is high or low whenever input voltage is within specific band. It is used to determine whether an unknown input is between two precise reference threshold voltages. Comparator can also be used as switching regulators. It can also be used as analog to digital converter. It converts analog input voltage to its digital representation. Then it can also be used as voltage to frequency converter. It can be used as schematic trigger. Schematic trigger is a comparator circuit with hysteresis implemented by applying positive feedback. The purpose of schematic trigger is to convert any regular or irregular shaped input waveform into a square wave output voltage or pulse. Thus, it can also be called a squaring circuit. This is the diagram of schematic trigger. Thank you. I hope you liked the video.